Alright, so I want you to get your date, your page number, your title, and your learning target down. We're going to talk about simplifying radicals. Make sure you get this organized in your notes. You've talked about simplifying radicals before. You talked about them in Algebra 1, and when we were doing quadratic formula. But instead of worrying about square roots now, we're going to be more into the higher order radicals. So we're talking about cubed root, fourth root, fifth root. So first I want you to consider and remind yourself what is the square root of 9. And the square root of 9, when I type that in my calculator, gives me 3. Now I want you to take the same calculator and take 9 to the 1/2 power. You should have gotten 3. Now I want you to take your calculator and underneath math, find the cubed root and take the cubed root of 64. And that should give you 4. Same thing, take 64 to the 1/3 power. And that also gives you 4. Let's do square root of 25. That should give you 5. And now I want you to take 25 to the 1/2 power. And that also gives you 5. So I want you to think about what you notice here. What you should have noticed is that the square root, which has an imaginary 2 here, turned into 1/2. And that the square root again, with an imaginary 2 here, turned into a 1/2. Cubed root turned into a 1/3. Therefore, if I wanted to rewrite the fourth root of something, that would turn into a 1/4 power. So we're going to try that. Go ahead and get your perfect cubes down, but you can write a radical in 2 different ways. You can use the symbol or a fractional exponent because they mean the same thing. So, for example, if I gave you the 7th root of a heart, if I was to rewrite that, I would take that heart and take the 1/7 power of it. That's the same thing. If I wanted to do the 9th root, or let's do the 8th, so we're doing an even number. If I did the 8th root of a triangle, and I wanted to rewrite that as a fraction, then I would do the triangle to the 1/8 power. Similarly, if I was to do the, let's do 5th root of the heart again, but we're going to square the heart. We're going to say that this heart is squared. Then I would take that heart to the 2/5 power, because I'd be multiplying this 2 here by 1/5, because this is the 5th root, and 2 times 1/5 is 2/5. So we're going to practice that. Take a second and rewrite all of these as radicals. So we're not simplifying yet, but this is what you should have gotten. You can simplify these, but this is what you should have gotten. Another way to write this middle one is to go ahead and square the 5 and make this the 7th root of 25. Both of those answers would have been acceptable. So now we're going to talk about how to simplify the radical. Once I know how to rewrite it, I should know how to simplify it from that point. So when I'm simplifying a radical, I'm breaking it down, and this number out here, my index, tells me how many repeat factors are needed. So if I go back to my perfect cubes, if you didn't write them down, you should have. I want to use those if I'm looking at the cubed root, and I want to use these if I'm looking at perfect squares. Because if I'm using the square root, then I need 2 repeat factors, because there's an imaginary 2 here that you don't usually write whenever you have the square root. If I'm looking for the cubed root, then there's a 3 here. So I would need perfect cubes, because these numbers will give me 3 matches. So for example, I need 2 matches for perfect square, for square root. So this is 9 times 9. That number, 81, would give me 2 matches. If 8 went into it, I would use if I was looking for the cubed root. If 8 went into it, this number 8 would give me 1, 2, 3 matches, because it's 2 times 2 times 2. Same thing with 125. I would use this if I was looking for cubed root, because 125 broken down is 5 times 5 times 5, and that would give me 3 matches. If I was looking for a square root, and 121 went into it. That breaks down to 11 times 11. I would use that because it gives me 2 matches. Square root. If it was a fourth root, then I would try to use numbers that are perfect fourth power. Same thing like for perfect fifth power. So let's look at example 1 for simplifying. So make sure that you specify that we're simplifying here, and here we were rewriting because that could be confusing later in your notes. So now we're going to simplify, and there's 2 different ways to go about this. My way is the singles club way that we did in Algebra 1. So like, for example, this is cubed root, so I'm going to need 3 matches, 3 repeats to be able to leave the radical. So I'm going to try to find a number in the perfect cube category because all these numbers in the perfect cubes have 3 repeats. See, 2 times 2 times 2. And 8 goes evenly in here. So I can break this down into 8 times 3 because 8 times 3 is 24. And the number 8 breaks down into 4 times 2. 3 doesn't break down. And the number 4 breaks down to 2 times 2. 2 doesn't break down. 3 again doesn't break down. And now I have 3 repeats. So the repeats are going to leave the radical, and left over single is a 3. And it was the cubed root, so I'm going to leave that 3 there to show that it was the cubed root. And that is this answer simplified. Another way to think about it, some of you do these this way, is that if I have the cubed root of 24, again, I want to find the biggest perfect cube that goes in there, so I'm looking here, which is 8. And I can break this down to the cubed root of 8 times the cubed root of 3. The cubed root of 8 is 2. And I'm left with 2 cubed root of 3. Either way, you get the same answer, and I'm okay with either. This one, before I start, I need to rewrite it. So, 1/2 power, which means I'm taking the square root, which means I need a repeat factor of 2. You don't have to put this 2 here. It's like putting a 1 in front of your x. So I'm talking about the square root because it's to the 1/2 power, and I'm taking x to the 6th. Okay, well, x to the 6th breaks down to x times x times x times x times x. 1, 2, 3, 4, 5, 6. That's x to the 6th. X times itself 6 times. So I need 2 repeat factors because it's to the 1/2 power. 2 repeat factors at square root. So I have 1, 2, 3 repeats of x's. So I have an x on the outside, 3 repeats with nothing left over. So this would actually be x to the 3rd power. That's the correct answer. Okay. Another way to think about it is to cut this exponent in half. You could multiply 6 times 1/2. What's half of 6? 3. We'll talk about this more tomorrow.